Okay, so if you know the meaning of time value of money, we can move to the next step, how to apply it. So, time value of money means the cash flow at different time point has different value. So the most common question we have is, if I have cash flow A at time point 1 and cash flow B at time 2, T2. So we cannot directly compare cash flow A with cash flow B just based on their amount. Why? Because they are cash flows at different time point. So what we can do is, first is to calculate the cash flow B's value at T1, then compare with cash flow A. Or we calculate cash flow A's value at T2 and compare with cash flow B. So how to do that? So in this example, it is a single cash flow. From T2 to T1, we calculate the present value. From T1 to T2, we calculate the future value. So we can define T1 as present, T2 and the future. So we have the tools here, the two formula. So if we have the money in the future and we want to learn its value at the present, so we basically multiply the amount with a present value factor. The present value factor is determined by two variables. One is time, number of periods, and I is interest per each period. And this is two factors as I talked in the class, right? So we can look up table 2 and find the factor, then we can apply into the formula. So if we have the value of the money now and we want to learn its future value, we can use table 1 and find out the future value factor, which is also determined by number of period and the interest per period. So here, I'm using the number of periods or interest per period. I do not use year or interest per year, because as we learned in the compound interest, different interest can be compound differently. Okay, for example, if I say the annual interest is 12%, okay, so this is annual interest rate. And now we have total number years, 3 years, okay? So if the interest is compound annually, so the interest per period, because it is annually compound, right? So each period represents a year. So the interest per period is 12%, and number of periods is 3. If it is compound semi-annually, so each year the interest will be compound every 6 months or half a year. So the interest per period or interest per half year will be 12 divided by 2. And number of periods is 3 years multiplied by 2 years, so it's 6. If it is compound monthly, so the interest per period or interest per month will be 1%. And number of periods with 3 years multiplied 12, so it's 36 periods. So that's why, when you purchase a house and apply for mortgage, 30 years. Okay, and when you look at your statement or the list of your future payments, you can find there are total 360 payments. Why? Because mortgage payments is monthly payment. Okay, so another is annuity. Annuity is a set of cash flow. It is very popular, like senior people when they receive Social Security or their pension, they receive the cash every month, receive their paycheck every month, right? So it's not single cash flow, it is set of cash flows. So for ordinary annuity, it is just like this. So for example, there's number n periods. Okay, so there are n periods. Ordinary annuity is there will be a rent at the end of each period. So total NR, okay? So this represents rent in period 1, this is represent rent in period 2, this is in period 3, this is period N. And the interval is the same. Okay, for example, if the period represents 1 month, so each represents 1 month. Same interval, and also the rent are the same amount. Okay, so this is ordinary annuity. For annuity deal, it is very similar. It is an annuity. The only difference is the rent is paid or received at the beginning of each period. Okay, so this represents the rent in period 1, this is rent in period 2, in period 3 is 4, period N. Okay, so to calculate the present value of this cash flow, I just use OA to represent ordinary annuity, okay, and use AD to represent annuity due. And to calculate the present value of this cash flow, we have NR rents at end of each period, right? So because the rent are the same, so we can actually just use the rent multiply the present value factor of the ordinary annuity. Okay, basically we can get the present value of all these cash flow at this point of time. If we calculate future value, so actually we can calculate the future value of these cash flows at this point of time. Same, if we want to calculate present value of annuity due, here we can apply this formula. It represents the present value of the annuity at this time point. Okay, and this is the present value factor of annuity due, which is available in the table 5. And if we want to calculate future value, there's no table, but there's no problem. Why? Because there's a relation between the present value factor of ordinary annuity and the future value of annuity due. Okay, so actually the present value factor of ordinary annuity, if we multiply 1 plus I, it is just equals present value factor of annuity due. If we want to learn the future value, the future value factor, this is F, sorry. Future value factor of ordinary annuity, we multiply 1 plus I. This will be the future value factor of annuity due. Okay, see, here I have this, right? Well, we will all multiply 1 plus I. So if we have table 3 and table 4, here we can also use them to determine the present value or future value factor of annuity due. Later on, I will have examples